So what I'm going to try to accomplish today is to walk through migrating a non-cloud application to a serverless app in AWS. I'm not necessarily going to go through all the code as I walk through this, though we can look at some of the code afterward if you're interested. My plan is more to give you a feel of all the moving parts and give you a sense for all the pieces that some of the other frameworks hide, and make sure you really understand all these components in AWS. There are a lot of them, but it is possible to knock out the kind of infrastructure you need for an application in not that long amount of time. And so we'll hopefully see that today. The application is an application I happen to have around. It's used to run a tabletop gaming convention, so it has some basic CRUD features that shows some data on this sample screen here. But the red part is the important part. It's an old technology, AngularJS, Spring and Hibernate. It's not convenient to host anywhere. There's a lot of opportunity for improvement. Let me just say that. But this year, I decided to work on the back end. So I'm moving the back end to AWS. Maybe next year we'll work on the front end. So why serverless? I could just put this whole thing in AWS on EC2, but it would run the same as today. I could run the same web container, I could run the same database, but then I would be responsible for the maintenance of that, backups, patching, blah, 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 and I'd be paying more to have this EC2 box running 24/7. So instead, if I run it as a serverless app, it can run virtually free. It's very easy to modularize the back end. And the only part that has any kind of cost at all, really, is the database. I'm going to be running a relational database, but even so, that's like $100 a year. It's very manageable. So in this talk, I'm going to try to avoid going through frameworks and tools that hide things from you. I want to just go into the console. I want you to see all the parts and how they relate to each other. And I'm not going to try to split this out into a huge number of lambdas, each with a very small bit of functionality, because it's just not manageable in a talk. But if you want to do that thing, this whole thing, the lambdas will all be hidden behind API gateway, so you can break them up and structure them any way you like. And the stuff I've done ahead of time, I set up an Amazon account, so you didn't have to watch me put my credit card in. And I set up the RDS database because it takes a little while to get the database up and running, and I didn't want to wait for that in the middle of the talk. The other things I already have on my machine are the AWS command line client and NVM for working with Node. But other than that, you'll see all the moving parts here. So on to the code. So this is what I did is I cloned the whole application as it was before. If we look in the source directory, there's Java code, there's the old Angular code. What I've done then is create a new empty Lambda directory to put things in, and we're going to start by implementing this backend Lambda that is just an empty directory right now. So that's where I'm going to start by putting some of the code for this application. So here we are. The one tool I'm going to use is going to let me build a TypeScript application into a Lambda. So there are a couple of config files I'm going to copy in here to get that running. There's a package.json that will define the Lambda function, and there's a gulp file that has the TypeScript integration. There's really nothing in it. If we look, it just says I want to use the Lambda TypeScript library. The package.json, just all the basic stuff. The only interesting part here is it has MySQL, because that's the database I'm going to be talking to. So I'm going to keep my fingers crossed that NPM runs moderately quickly during this talk, because otherwise we're going to spend a lot of time on small talk while we watch it operate. Go, go, go. Here we are. OK, and then I'm going to run the gulp task to set up a basic TypeScript operation here. So now if we look at that backend directory. I have an index.ts. This is where my Lambda handler function is going to go. They put a default one in there. And there's a Lambda config file, which I'm going to need to fill out to tell this how it should put my application into AWS, which account to use, and things like that. We'll go through those settings in a second. So there's one more piece of common code I'm going to copy in here, which has some handler functions for some helper functions for the Lambda to send an HTTP response or send an error if I need to. Okay, so I'm going to do a little copy and paste of code here so that you don't have to watch me type it all, but we'll point out what it's doing. Okay, so this handler function now, right now it's just returning a simple JSON object with a message. So I just want to get the most minimal Lambda operating, and then we'll connect it to the database and make it a little more fancy. So now is when we need to go look at this Lambda config. And there's a couple more settings to put in there. This is just a helper, again, to help publish this Lambda. So I want to be in US East. Now, the two things that I need to get working, I need a profile so I can use command line tools to connect to AWS. I need to specify an account that has permissions to operate on AWS from the command line. And I need to specify a role that will specify the permissions for my Lambda function, what that Lambda is allowed to do. It needs to be able to write log files. It needs to be able to talk to some other AWS services. So we'll get that going. It needs to be able to talk to the database as well. So to start with, I'm going to go into the AWS console and set up the user account to do this. You do that in IAM. I'm going to create a new user, call it console admin, because it's going to have administrative permissions to run things from the console. It's going to be programmatic access. I want it to run from the command line, rather. I'll create a group called admins. I'll give it administrator access. Okay, so these are the settings I'm going to need to put into my command line configuration to get this working. So the access key goes first, and then the secret key. Big secret, huh? I'm showing it to all the world. Okay, so now going to test that it doesn't blow up. And it didn't, so that's good. I do need to put in a default region for some of the commands I'm going to run later. Again, US East 1. Okay. Now I need to create the role that's going to give the Lambda function permissions to execute. In AWS, nothing has permissions to do anything by default. So we have to add on the permissions we want to grant to something. So I'm going to create a role that gives permissions to a Lambda function. The policies I need. One of these is the database runs in a virtual private cloud, a VPC, and so the Lambda has to be able to run in the VPC as well. And this role just gives the basic permission for one Lambda to call another Lambda. We'll talk a bit later about why that's necessary. So with those two permissions, I don't need tags. I'll call this Lambda runtime. I should have a role now that, if we look at it, is able to run in a VPC and call other Lambdas. There's one other thing I want it to be able to do. And that's to call Cognito for authentication, to log someone in, to create a new account, things like that. And there's no convenient canned policy for that, so I'm going to create one. And the easiest way to create one is to copy and paste from the internet, Stack Overflow or whatever. So this is allowing this Lambda to do pretty much anything with Cognito. And I need that. I will be calling all administrative functions in Cognito to create users and things like that. All right, so now I've got that policy created, and I just need to attach it to my role. Reload the page here. All right, there's my Cognito policy. Okay, so now if we look at Lambda runtime, it can run in a VPC, it can call Cognito, and it can call other Lambda functions, which is all I need for right now. And the way I'm going to refer to it is by this role ARN. And ARN is just a unique identifier in Amazon speak. So I'm putting that into my config file. So in the command line interface settings, I define this ETE profile. In the console, I just define this role. I can bump up the memory size here. And that should be enough to get this operation going. So let's see now if we can deploy this Lambda. Oh, OK. So the other thing is there's a bunch of TypeScript settings. The linter is pretty anal by default, so I'm going to take care of that. I don't really care which kind of quotation marks I use. I don't know why that's so important, but all right, let's try this again. Without the error messages this time. All right, so here goes the Lambda. I still have consecutive blank lines, but at least it'll run OK with a consecutive blank lines error. All right, it's uploading, and there we go. So if we go back into the console now and I look into Lambda, there's my Lambda. And I'd like to test it. So I'm going to configure a test event. Hello world is fine. It doesn't really matter. And test it. OK. So what I get here is that message, hello ETE, which if we looked back at the code, there's the message, hello ETE. So that much worked. Now the next thing I want to do is put this behind API gateway so we can call these Lambdas in a reasonable way through a REST interface. So I'm going to go back to the console and go into API gateway. And I need to create a new API. I'm going to create it from scratch. The name of this application for running conventions is naturally Con Artist. All right, so we start out with an empty API. I'm going to create the resources that I want to be in my API. Now, I'm going to create this as a proxy. And what that means is no matter what you send through this path, it's going to get sent to my Lambda. And my Lambda is then going to decode that and do the right thing. I tried for a while to use the non-proxy interface, and the amount of configuration required is just insane. there's my lambda. All right. I'm going to try deploying this, and we'll see if we can call the same thing through the API gateway, through the browser. OK, and here's my URL. All right. So I need to put the /API/something on the end. And there's my message, hello ET. So, woohoo. So I've uploaded Lambda, I've created an API gateway, and I'm now calling through the API gateway into the Lambda. There's a few more things we want to do to this setup. We want to have a test in a production environment, and we want to add security. So those are the next couple of things. Then we'll actually get the database hooked up. So in order to have a test in a production environment, I need to define test and production versions of the Lambda, and then test and production URLs and API gateway that connect up to that. So to start with, I'm going to create a fixed version of the Lambda. So now we have a version, and then I'm going to create test and production aliases. And the test is going to point to the latest code no matter what. And production is going to point to a fixed version of the code so that as I play around in the test environment, I don't mess up production. So that's going to point to version 1 always, instead of pointing to the latest code. So now if I look, I have production pointing to version 1 and test pointing to the latest code. So now I can go into API gateway and hook it up. Now what I want to do here is I want to have it point to have two different deployments of the API, one test and one production. And the stage variables are what I'll use to control then calling the right Lambda. So I'm going to add a stage variable with a value of test in the test deployment. I need to go and deploy again to production. And then I can set up the stage variable in the production. OK, now I can go back to my Lambda setup, and I will change it to call a specific version of that Lambda controlled by that stage variable. Now I need, no, that didn't work right. Forgot the $sign. OK. I need to manually run commands to give it permissions to do this. It's a little silly that it can't do that automatically, but whatever. And to get this command to work right, I need to specify the right profile. Oops, I did not hit the lock button. OK. So I'm first going to run it to give permissions to call the test release of the Lambda. And then run it again to give it permission to call the production version. All right. So that's working. Now I just need to redeploy this. Deploy it first to test. OK, and then I'll deploy it again to production, and we'll try these URLs and see if we get different versions of the code running. OK, so now I've got the same thing running in the test and prod. So I need to push out a new version so I can tell the difference. So upload a new version of the Lambda. And because the production release is pointing at that fixed version, it should see the old code, and the test release should see this latest one that I'm pushing out right now. So we should see two different messages at those two different URLs. Once again, as soon as npm finishes here. Okay. So now if I look at the test version, I see hello test. I wonder if I can make that bigger. And if I look at the production version, oops, I also see hello test. That's not good. I've done something wrong. Did I not deploy to production? There we go. Okay. So the production is showing the original version 1 message, and the test is showing the new one. So that's working. What's that? I must have, when I deployed the API with that stage variable in it, I must have deployed it to test twice by accident. So I went back and just deployed to production again. So now let's get it to talk to the database. So got a couple config files to put in so we can get it going with the database. And okay. Ugh. That's why I use a compiler. Okay. So what's different now? Come on. There we go. I've added a database config file. I need to put the right database URL in there. So let's take a quick look into RDS. This is sort of the life of going through it this way. You get to flip through all these different services in the console. Okay, here's the database host name. So I'll put that in here. That's my test one from my trial run earlier. We don't want to use that. Okay, so we don't have a password in here. I'm going to put that in the Lambda configuration data. And then I'm going to put in some code so we can tell if this database connection is actually working. So instead of just returning a fixed message now, I'm going to just run a query of the player table. All right, so I've added in this handlers directory, I've added some kind of boilerplate code that just creates a database connection pool and knows how to execute a query, things like that. So now, when this handler is called, it's going to go into an asynchronous mode. It's going to get a connection, get a promise with a connection. It's going to then use that connection and run a query, a promise, to get some results. And when those results finally come back, then it's going to send the message back to the user interface. And it's important here to have this, to turn off this callback waits for empty event loop, because I'm leaving this database connection pool open. As long as this instance of the Lambda is live, I can reuse that same database connection instead of reopening the MySQL connection every time. So if I didn't have this setting in here, then the Lambda would never end, because it would say there's still some code running out there because the database connection pool had an open connection. All right, so now I can upload this Lambda again, but it's not going to work quite yet. And the reason is that the RDS database is in its virtual private cloud. That's how Amazon wants the databases to be set up. And the Lambda function isn't able to talk to that virtual private cloud. For some reason, there's not a way to say, I want any code running in Lambda or any code running in Amazon to access my database. The only way you can do it is to explicitly put the Lambda in the same virtual private cloud as the database. And that'll cause us some problems later, but for now, it's good enough to get things running. So I've deployed the Lambda. We're going to have another look at the Lambda console. And the first thing I need to do is put in an environment variable for the password, another highly secure one. And I'll save that. Okay, and then I need to set up the VPC. So I'm putting it in the default VPC, which is where my database is. I'm going to add it to all these subnets. It's a bunch of networking nonsense. Why does a developer have to deal with this? I'm giving it a security group. So now we're almost there. Now the Lambda can run in the virtual private cloud where the database is, but it still doesn't have permission to talk to the database yet. So we need to go into the security group for the database and tell it to accept inbound connections from that security group where the Lambda is. All right, so now it ought to work. So we're going to go back to the Lambda console and try running my test event again. And this time it's taking a little longer. The first time it runs a Lambda in a VPC, it has to set up all the networking connections, and it takes more like 10 seconds. Let's see what we got. Here it is. So it ran my SQL count statement correctly, and it's showing that there are 464 players in the database from this convention. So we now have a Lambda that's talking to a database, so that's good progress. Then the next thing I want to get going is security, which I'm going to do through Cognito. So if I use Cognito to manage my users, then when a user gets a token from Cognito, they can pass that to API Gateway, and I can just turn on authentication with almost no effort for my whole REST API. Or pick individual endpoints to secure, whatever the case may be. So that's pretty handy. So let's get into Cognito. Before I go to Cognito, I need to set up an email address so that Cognito wants to be able to send emails out. So we'll start email service. All right, I've verified my email address. Just double check that, and then we can go into Cognito. Yep. Okay. So Cognito. So in Cognito, I need to create a user pool. I'm going to add one custom attribute. In my database, I have information on all these people who are going to have Cognito accounts. And I want to be able to get from one to the other. So the database, I'd like to know the username they're going to use in Cognito, and in Cognito, I'd like to use the player ID in the database. So I'm adding a custom field for that. Okay. Now, there are some emails that Cognito sends out when people sign up or forget their password. The first one, they're not described very well here. The first one is the one you get for a forgotten password. And the second one is the one you get for a new account. So you can give more elaborate messages here, but that's enough for the moment. We're going to add the app client later. I missed a checkbox. So let's fix that. Yes. There was a problem updating the pool. Oh, worked on the second try. And I'm going to add an app client, which is another thing. That we'll need to work with Cognito. Okay, so now all the Cognito settings are ready. We just need to go and put that into the app. Now, here's where I run into trouble. I put my Lambda function in a VPC so I can live with the database. From within the VPC, you can't call Cognito. So I could pull the Lambda function out of the VPC, but then it can't talk to the database. So, who thought this one up? So from within a VPC, there are some magic settings you can use to connect to things like S3, but they don't have one for Cognito. So there's a special API you can activate to talk to Cognito if you want to pay through the nose, or you can add just a regular old internet gateway, again, if you want to pay through the nose. So I don't want to do that. So I'm going to create a second Lambda function. So I'm going to have one Lambda function living outside the VPC that can talk to Cognito, and a second one living inside the VPC that can talk to the database. And this is why earlier on, when I was setting up the permissions, I wanted to allow one Lambda function to call another one, just so that I can have these two Lambda functions talk to each other. So I started that one off with a little code, so you don't have to watch me copy config files again. But I didn't put the Lambda configuration in. I'm going to call this one account. I can talk to Cognito. It's going to use the same role, so it has the same permissions and all that stuff. And I just need to replace the function handler with something that will actually work. Okay. All right, and then I need to copy in the actual code for that. Okay, so I have some functions in here that I've written before, and we can, again, go through some of this code in more detail afterward if you like. But it handles the Cognito calls to create a new user, to log someone in, to refresh a token, and things like that. So now I have the Cognito part going, but in order to do the coordination with the database, I need a little more code in my backend Lambda. Now this backend Lambda is going to be able to be called three different ways. One way is through the API gateway, through the REST interface. One way is through the console when I just want to run a little test, and I hit the test button in the console. And the last way is if the account Lambda living outside the VPC calls the database Lambda inside the VPC. All right, so I've added this code to say, if we didn't get a HTTP path or HTTP method, then it was clearly not called by API gateway. So either it was called by the other Lambda if it has, these well-known settings, or else it must have been called by the console, and then I'm just going to return this, test event is true, just to prove that the thing is working. And again, I have some code I put in earlier that looks up accounts in the database and updates an account to indicate that it's been activated. And we can have a look at that later if we want. So I need to push both these lambdas, and then I'll need to put in some environment variables for the cognito. Uh-oh. That was an actual error. I did something wrong in the count lambda. Ah. Okay, so the database lambda went through. We're just waiting on the account lambda. I have a thing. I should have taken out the consecutive blank lines warning in my linter config, I guess. Okay. So now let's see if we can get this going. If I look back in the console for lambdas, I have 2 now. The account lambda needs the cognito settings. So I'm going to have a cognito pool ID. Oops. And a cognito client ID. I'm going to copy these from the cognito screen. So here's the client ID. And here's the pool ID. Save that. Okay, and then I need to configure test events. So I have 2 test events I can run. The first one will look up a user from the database and create a URL for them to click to activate their account, and the second one will actually activate the account. I'm not putting the screens all together for this because there are several of them and it would take too long. I'm just going to use test events for it. So I have 2 test events. The first one is to find a user and send them their link to click. And the second one is to activate their account. Okay, so let's try running the first one. Something didn't go right here. Oh, it's down here. All right, here is the confirmation code I need. So I'm going to put that into the I'm going to put that into my second test event. I'll try running that. All right, so if all went well, oh, validation error. I have a space in the configuration, maybe? Yeah. Okay. Try that again. All right, so this is the important thing. Now I've created an account and I get the tokens I need to use that account. So I'm going to copy these out, and we will try now to hook up the API with this cognito. With this cognito pool, so we'll have authentication and API gateway, and then we'll see that we need one of those tokens to actually call the function. So here, before we, I need to set up the authorizer first. I need to tell it I want cognito to authorize calls to API gateway. Okay, and it hasn't found it yet. I'm going to reload the page. this again. There we go. So now it should only allow me through to call this API if I have a actual token from Cognito. The only subtlety here is if there's a CORS situation, I want to be able to do the same thing but without any security, because I want to be able to call the options method without security, and then the get or post I want security on. So this is going to be backend. This time I don't need to run that command because it's just giving me the same as before. It's for the same API call. So now this should be ready to go. I have no authentication on the options, but I have the authentication on the regular API. So we'll deploy this to test and check it out. Okay, so if I look, this is test. There we go. I got the unauthorized error. And production still works OK because I didn't deploy that to production. So in order to get around this authorization error, I have to actually go into Postman and put the right header in there. So I'm going to take the same URL. I'm going to go into Postman. I'm going to call it get. I need to give it a header. And then I need to put the ID token I got into that authorization header. So I'm just copying, pasting this out of the response I got earlier. Okay. Unauthorized. Well, that wasn't what I was hoping for. Did I put in the wrong header name? Maybe. Authentication. Put in the wrong header name. There we go. Okay. And then you can see if I take this token and put in, some junk in it, then it doesn't work anymore. If I take the stuff out, then it works again. So you can now get to this API if you have a legitimate token from Cognito, and if you don't, you can't. So what are we up to? So the last thing I want to do today is actually get the UI working at least a little bit so you can log in and maybe see some data, and then hopefully we'll have time for some questions or to look at code in a little more detail or whatever you guys want to do. So I need to put a little bit more logic into the app. Okay, so I'm going to run this app locally. And as a result, my URL is going to be localhost, and when it calls that API URL, it's going to be a CORS request. When I do this for real, I'm going to set it up in CloudFront. And in CloudFront, you can have everything living on the same host name, the API, the static content. We can walk through that later if we have time and you want to. But that's not going to be the case when I run it locally. So I'm going to need to put in the handler for the options. And then I'm going to put in some code to pull apart the request URL in more detail. And then call the actual function. Okay, so I've added a little bit more code to the back end. If we look at it's running some SQL queries here. If you sign into the application, it's going to look up what conventions or events you have permissions to access, and that'll get the UI through the initial sign-in process. So let's deploy that. I'll start. I've done something wrong again. This is why I need a compiler. This is why it's in TypeScript instead of JavaScript. Okay. Now I need to pull up one of the other windows here. Okay, I'm running the old web container to run the static content, basically. I've stripped out the actual Spring servlet, so it's only the static content, but that's the most convenient way to get it up and running right at the moment. The one thing I'm going to need to do is substitute in the right AWS URL for that API gateway. So we're going to point it to the test stage, copy this URL, and I'm going to put it in right here. So what I did when I went to overhaul the UI code to call this new backend is I just put in some boilerplate to put the ID token in the header, and now I think I've named the header the wrong thing, so I may need to adjust that. Authorizers, I call it authentication. It's done. Where did I actually? Okay. And other than that, I just switched the URLs to call this new API prefix instead of the old one. So I'm not again going through that in tremendous detail, but now this is the same front-end code as before, just with a tiny tweak to the class that calls the server API. So I'm just building the code with that change I just put in, and I'll try to run this. Okay, so it got some kind of error, which is probably just that there's one more function I need to implement. Oh no, it was the CORS failure. Put the options handler in. Why did it get a CORS failure? Okay. I need to update API gateway to reflect the new Lambda. So let's put that in. Create a resource. This is the account API. It's going to be a proxy resource again. This is going to go with the account Lambda. I got to go through this little exercise again. Thank you, autocorrect. Okay, I need to actually set up the alias in Lambda first before I can run that. So back to Lambda. So we go to the account function, publish. Create the test and prod aliases. Test points to latest. So the same as we did for the backend Lambda. Just doing it for the other Lambda now. Prod always points to version 1. Okay, now I'll try running that again. There we go. I ran it on test, now I need to run it for prod. Okay, so let's deploy that. All right, now I'll try the UI again. That's over here. Still didn't like it. Account, sign in, test account, sign in. So I've missed something. In API gateway, I've got the account, sign in, doesn't have any security, should be calling the, okay, I can go ahead and make a test call. All right, well, I may leave it here so that we can, if you have any questions, we can talk about that rather than spend my last couple of minutes debugging. So let me bring up the Q&A interface in case anyone has. Oh, this is going to just bump me right back out again. Salon D. Okay, so I'll just go through some questions here and then we can talk more afterward if you want to hang out. Does the concept of connection pooling exist in Lambda? No, that's one of the frustrations. It doesn't have any built-in support for connection pooling. Now, in the code for my Lambda, I put in a MySQL connection pool so that if my instance of the Lambda is used over and over again, it will use those pool connections again. But the disadvantage is there's no notification when that Lambda instance is destroyed. So the only way that MySQL will know that it should shut down is if that connection times out. You know, the instance starts, it pools a connection, it reuses it and reuses it, and the instance is whacked. But MySQL thinks it's still there. So you know, that connection will eventually be reclaimed when MySQL notices that it's dead, but not until then. So it would be great if they would put in some kind of shutdown hook or some kind of connection pooling support to really make that bulletproof, but that doesn't exist today. The next one, is the code and setup going to be available? What's going to be available is kind of a step-by-step, you know, these are the things I went through. The specific code is not going to be available, but there is going to be a video of the session posted online. So there will be a blog post on the Chariot site talking about, you know, the individual steps I went through and the different services I used, and then you can refer to the video as well. The next one, does it launch a new JVM for each call? So because I'm using TypeScript, it compiled to JavaScript, so it's actually a new node rather than a new JVM, but the concept is the same. For Java code, it would be a JVM. what it does is it spins up a Lambda, it starts the JVM or the node environment, and then that might last for 10 minutes, might last for a half an hour. If it doesn't get called again, it's going to get shut down. If you have fairly continuous calls coming in, then it'll stay alive. And then if you end up with multiple simultaneous calls, you might get more than one instance. And then some of those will be reclaimed over time. If you really want to make sure that you never, I won't say you never. If you want to try to avoid that startup delay to the greatest extent possible, you can have a job somewhere or a hosted service somewhere that just pings it every minute or two. But you can't totally prevent it. If at the same moment two of us try to hit this and it only has one instance living, then one of us is going to get that fast instance and the other person is going to cause a new instance to start up. So every once in a while you may get that startup delay. For a regular Lambda, it's hardly noticeable. It goes very quickly. But the Lambdas in the VPC with the database, they take longer to start up. Those are the ones you notice. So it may not be a bad idea to have a spinner or something in the user interface when you're making one of these calls. The next one is for an application with a ton of requests per day. What's cheaper, EC2 or Lambda? I don't have an answer to that. We would have to kind of run the numbers and look at the usage. You can compare the EC2, running an EC2 instance 24/7 or however many EC2 instances you would want, and then look at the number of requests. Lambda is billed as the number of requests times the memory usage times the amount of time the request takes. Maybe, sorry, I didn't say that right. It adds up the memory usage times the amount of time the request took. It adds all that up and you get charged for the sum of that. So, if you figure out how long your requests take and look at the memory usage you've configured for the Lambda and then look at how many requests you have, you can add up the numbers and figure out which one is going to be a better deal. One of the subtleties to be aware of is if you bump up the memory usage on your Lambda, it gives it more CPU power as well. So the whole thing might run faster. So for a intense kind of request, it may be cheaper to bump the memory up because then the whole thing runs faster and the total memory time speed might go down or might stay the same. So it's not always bad to put the memory up. Okay, can Lambda be chained? Yeah, so in my example, if you called the account Lambda, one of the things it does, where's a good example? The account Lambda, when you call, you're trying to look up an existing account to send this confirmation email to them. It then calls the database Lambda right here. And the code for that looks like this. This is the JavaScript API for one Lambda to call another one, or for anything to call Lambda, really. So it's passing in, the function name you want to call in the payload, and it gets back a result, which then it decodes. This is just some of my boilerplate code here. But yes, you can have one Lambda directly call another. The other thing you can do is put message queues in between or things like that. If it's not a synchronous operation, you can have a Lambda put something on a queue, and then when the thing gets taken off the queue, it can call a different Lambda. You can chain things in different ways. In a different app, I had a Lambda that, again, was in a VPC with a database, and then it wrote a file to S3, which is allowed. From within a VPC, you can talk to S3, also DynamoDB. I think those are the two services you can talk to from a VPC. So it would write a file to S3, and then the file written in S3 would create an event that triggered a different Lambda. So there are different ways you can chain these depending on what effects and what operations you want to perform. Can you preserve logs? Yes, the logs for these Lambdas, I didn't show it. They go into CloudWatch. So if we look in monitoring here, view logs in CloudWatch. these are the invocations of this Lambda. It has a version number there. It rolls over every once in a while. But here are the, it's going to be more meaningful, I guess, if we look at the one that talks to a database, because I actually had some log output in that. So let me switch to backend, CloudWatch logs. Oh, not there. Okay, here it is initializing the MySQL pool. So when it went to initialize the MySQL pool, it did that once when it started up, and then it handled all these requests afterward without reinitializing the pool. So you can see there that that Lambda instance was kept alive, and the same database connection pool was used for the subsequent request. But here's all the log output preserved in CloudWatch, and you can configure CloudWatch to do your log retention however you want. You will eventually pay for it. In running this application, I never got charged for anything except for the database. I have another application in AWS, that's configured more or less the same way. It uses a lot of bandwidth. It's sending 3D files back and forth, and they tend to be large. And I run that all through CloudFront, and you pay for CloudFront bandwidth, and I've gotten bills, for using, tens of gigabytes of data. I get a bill for like 13 cents or something like that. So it's really very economical. The free tier covers a tremendous amount of Lambda usage. Not 500 million, maybe, but a pretty decent amount of Lambda usage. And again, really the only thing you pay for on a small scale like this is the database. All right, thank you. It's 5 o'clock. Have a great day.